So today we're going to learn how to solve equations by factoring. Many of you ask, why do we need to learn how to factor? Well, today hopefully you will see the part of the reason why we need to be able to factor. And also, look, we're solving now. So that means so far we've had these polynomials as an expression, right? Now, guess what we're going to get? Equations. Okay, so now we're going to be actually solving. Okay, instead of factoring or simplifying these things, right? We'll be solving these. So how do we solve these equations? Well, we know how to solve some of the equations, right? Linear equation, we know how to solve, right? Like 2x plus 1 equals to 5. You know how to solve those things, right? But we don't know how to solve things with x squares, yet. You know what I mean? So whenever you have like equations that are non-linear, meaning not x to the first power, but x to the second, x to the third, whatever, we need to know how to solve these things. And factoring is one of the ways of solving these equations. Is that okay? But, Jason, the idea is really simple. Let me ask you this, okay? Jason, if a or b is equal to 0, what can you tell me about a times b? This is 0. Is this a very simple idea? Right? Isn't this a very simple idea, guys? Okay. So what if I change what's inside? What if I change the one in red with the one in blue? In other words, by the way, there's a name for that. You see how this is an if and then statement? It's called a conditional. If you switch what's inside the if part with the what's inside the then part, it's called, anybody know what it's called? When you switch this is called the hypothesis and the conclusion. No one remembers? This is from intro, no? It starts with C. When you switch these order around. Yeah. Converse, that's right. It's not the shoes, Converse, but that's what it's called, converse. When you change the if part with the then part, it's called converse. So what do you think? What happens if I change the converse? I mean, if I change if a times b equals 0, then what can you conclude? Anybody? Yeah, a's got to be 0 or b has to be 0. Is this a very simple idea or not? This is a very simple idea, right? Is there any other way? Like, can a be like half and b be half or something? Can a be half and b be negative half? Would it give you 0 when you multiply? No. That's when you add, right? Half plus negative half would be 0 if you add them. But when you multiply, how do you get answer equal to 0 when you multiply two things? One of them has to be 0. Right? That's the only way. Isn't that right? Right? They could both be 0, but do they have to be? Like, a could be 1 million, but b could be what? 0. Then the whole thing is 0. A could be 0, and b could be negative 1 million. Would it still be 0?
0.
Yeah. So we're going to use this idea, Jason, to solve equations that are not linear. Okay, let's see whether does that make sense? So I'll give you an example, okay? So of course, they're not going to just use a and b, right? They're going to get more creative, right? Instead of a times b, guess what? They're going to use some
numbers.
Well, if you write numbers, if a is like 5, there's no way 5 could be 0, right? So it's got to be some. Okay, good. Some polynomials. Okay, let me get you. Okay, here's example 1, guys. So instead of just a and b, they got really creative. They use a binomial, right? Like I said, if a and b is some number, can number like 5? Can 5 be 0? No, 5 is always 5. That's why it's called constant, right? Constant. Anyway, so for this though, what is your a in this case?
K minus 3.
It's not k, it's x. Okay. So what is your a? X minus 3. What is your b this time? Okay, this will be true if what?
1 will equal 0.
Yeah, if, so this is how you do these, okay? Right? If x minus 3 is equal to what? 0 or what? If x minus 4 equals 0. And now, do we know how to solve these linear equations? Yeah, you do. How do you solve x minus 3 equals 0? When is this true?
Oh, 3.
Yeah, you add 3 to both sides. What about this one? You subtract 4 from both sides. So what? Guess what? This time, how many solutions do you get? 2. This is true when x equals to what? 3 or x equals to negative 4. That's all you do. It's very simple, right? It's just following that simple idea that when you multiply two things, and if the product equals to 0, right? it's got to be, one of them has to be 0 for that to be true. That's the only way. That's the only way that's true. By the way, you could write it as a brace, using brace. And write this in increasing order, okay? So -4 and then 3. Of course, 3 is bigger than -4, right? Did you get the idea? So instead of A and B, they're going to give you some polynomials there. So you could either write it this way, x equals to 3, or x equals -4, or you use this. So either way, which way you like, you should know how to do both of them. But yeah, okay. So does this make sense?
Yeah.
Did you have questions, sir? Yeah.
Are all the columns with a 0 on one side?
Okay, very good question. Hold on to that thought. If it does not equal to 0, guess what?
We don't do it?
You're right, you wish. If it doesn't equal 0, then no. Okay, we'll get there. Hold on. Okay, so right. Any question on this, by the way? Does this make sense? So, Tajivar, actually, I'm glad you asked that. If it didn't equal to 0, you have to make it equal to 0 in order to use this property, right? By the way, this has actually a name.
Property of 0.
Property of 0? No. It's called? No, look. Aren't we multiplying these together? And when you multiply two things together, like A times B, it equals to 0, right? So what word do you think has to be in when you're multiplying two things?
Product together.
Okay, so there you go. It's called zero product property. And this is pretty easy. What do you think this zero product property says? If A times B equals to 0, guess what? A has to be 0 or B has to be 0. That's exactly what we just did, right? So that's what this, there's a name for this property. So when you're solving equations that are not linear, okay, like x to the second power, x to the third, and so forth, you need to use this property called zero product property. It's saying that if you have an equation that equals to 0, but not any equation, you have to have a product. If a product equals 0, each of those factors must be 0. There's no other way for the whole thing to be 0, right? So we're going to use this simple fact to solve these equations that are not linear. Okay, so write this down. Here, take a look at example 2 now. Okay, 6x times x plus 5 times x plus 2 equals 0. Right? By the way, this time, what is your A?
X plus 5. X plus 5. 6x.
Okay, do we just have 2 factors, or do we have 3 factors now?
We have 3.
Yeah, is it okay to have 3 factors? Does it work the same way? Yeah, it doesn't have to be just A times B. It could be A times B times C equals 0, right? And of course, A could be 0, B could be 0, or C could be 0, right? So here, what is your A? 6x. What is your B?
X plus 5.
X plus 5. What is your C?
X plus 2.
X plus 2. And do they all equal to 0? Yeah, could we use zero product property now? Yeah, it equals to 0, and do we have a product on the left side? Yeah, in order to use zero product property, you have to have 2 things. The whole thing has to equal to 0, and you have to have a product, right? Which means you have to have factors on the left. Does that make sense? Is the left side factored? Yeah. Kali?
Are there 3 answers to this?
Yes. So there's going to be 3 answers, whereas the other one we had 2, right? No, what if I had 4 factors? How many answers do you think? Yeah, I'm going to get 4. That's the idea. Does that make sense? So this is only true if what? Who could tell me? What's the first case? Yes. If 6x equals 0, or what else? X. X plus 5 could be 0, right? That's not the case. What's the third case? Yeah. Exactly. Or if x plus 2 is equal to 0. And do we know how to solve these simple... Okay, questions? Okay, then do we know how to solve these simple linear equations? These are linear equations we know how to solve, right? So how do you solve 6x equals 0? When is this true? Yeah. Divided by 6. What's 0 over 6? When you divide by 6, don't you get 0 over 6? What's 0 over 6, class? 0. Isn't it undefined? Yeah. No. 0 over 6 is 0. When do you get undefined? Yeah. When you're dividing 0, right? If you're dividing 0, if the 0 is on the denominator. This time that's not what's happening. 0 is on the numerator. That's okay, right? Divide both sides by 6. What about x plus 5 equals 0? How are you going to solve that, guys? Subtract 5 from both sides. What about x plus 2 equals 0? Is this easy or not?
Yes.
Okay, so how many solutions do you get? Like Holly said, we get 3. We get x equals to 0, or x equals to -5, or x equals to -2. And of course, if you were to write this using brace, the set notation, you would write this in increasing order. Yeah, so you would write -5, -2, or 0. So you have 3 solutions for this. Yes, sir. Question?
So when you're saying if something equals 0, like say for 6x, that means you take away x plus 5 and x plus 2 from the equation and you just solve it.
Right. So, for example, look, what we're saying here is that if you plug in x equals to 0, the whole thing will be 0, right? So let's verify. What's 6 times 0? 0. So that's 0 times something, isn't it? But what's 0 plus 5? That's 5. What's 0 plus 2? So but this becomes 5 and 2. It doesn't matter, right? Because we're going to be multiplying the whole thing by 0. So we're not saying all three factors are going to be 0. One of them will be 0. When x equals 0, 6x will be 0. When x equals to negative 5, x plus 5 will be 0. Right? Whereas the other one will be some number. Right? When x equals to negative 2, this factor will be 0. So 0 times some number is going to be 0. That's what we're saying. Right? Yeah, question?
Would it be binomial?
Yeah, sometimes you could have binomial. What do you mean?
A plus B. I mean, like x plus 5 plus x plus 2.
Oh, so the question is, what if the left side is not, right? Doesn't look like it's factored, right? Very good. Hold on to that thought, okay? Because okay, we'll get there in a minute. Any question on this? Very good question, actually. May I move on? Okay, let's move on to example 3 then. Okay, take a look at example 3 here. 5y squared is equal to 80. This is y to the second power, so it's not a linear equation. We don't know how to solve those. So, but can we use zero product property right now?
No.
No, you cannot. Remember, zero product property, what do you need? You need two things. You need 0 and you need product. You need product on the left side. Do we have the whole equation equal to 0? No.
Oh, you should take away the 3.
So what are we going to do first, guys? Michael? Yeah, always simplify, right? Doesn't 5 go into 80? So divide both sides by 5 and see if that helps us. And I'm going to do that right now. Okay, good. So are we ready to then use zero product property now?
No.
No, we're still not ready because it doesn't equal to 0. It equals to 16, right? So we don't know how to do that. So guess what we're going to do next? We sort of talked about this before. Yeah, Carolyn. We don't know how to square. When you square root both sides, that's a shortcut. We're going to learn that later. Don't worry about that right now. We don't know how to do that yet, okay? So, yeah, Camilla? Subtract 16. Thank you. Why do we want to subtract 16 from both sides? Yes. Then you would have difference of two squares on the left. And not only that, you will get what? You will get 0 on the right side. So we're almost ready to use zero product property, aren't we? The whole thing equals to 0. But do we have product on the left side? No, but just like you guys said, what is y squared minus 16? What can we do with that? Yeah, it's a difference of two squares, isn't it? So could we write it as a product, meaning could we factor?
Yes.
Yes, we can.
Yes, you can. Why can't we just square root it?
We'll learn that later because when you do that, it's a shortcut. Many people make a mistake by doing it. And you get the answer as 4, that would not be the answer. Yeah, so hold on to that. Okay, so now, what do I get here? Then on the left side it becomes, yes sir, Matthew? Is it y plus 4 or is it y plus 2? Oh wait, you're right, it's y plus 4. I thought it was 4 here. It is 4 squared, so you're right. It's y plus 4 times y minus 4. Matthew is correct, I was wrong. Okay, so there you are. Does that make sense? Yeah, it was 16, wasn't it? So 16 is 4 squared. Now, Matthew, okay. Matthew got this right. So Matthew, what do I do next? Do we have the left side as a product? Now, can we use zero product property? Matthew is correct. How many people agree? Okay, how many people know then what to do next? So we have the left side as product. Now, we're ready to use zero product property. Guys, whenever you use zero product property, check those two things. Does it equal to 0, first of all, and do you have a product on the left side? In other words, do you have it factored? Okay, so when would this be true? Go ahead, everybody try it out. I'll wait. Class, when would this be true? This is true only if what? If y minus 4 equals 0 or? Right. And do we know how to solve these simply linear equations? Yeah. So Royce, what do we get? Royce?
Y equals negative 4 or y equals 4.
Well, the first one becomes 4, doesn't it?
Yeah.
Oh, okay. I see what you did. So here, you get y equals 4, y equals negative 4, but when you write in a brace, you write the smaller one first. So that's why you said y equals negative 4 first, right? So you get two solutions for this. Does this make sense?
Yeah.
So again, how many things do you need for you to use zero product property? Two things, right? What is it that you have to check? That the equation has to equal to? Zero. And secondly, it has to be a product. It has to be a factor. Okay. So let's move on to next example. Look at example 4. Some of you are asking something like this. Like Samuel, you asked, what if you get just a binomial on the left side, right? Something like this. So we got 6x squared plus 11x equals to 10. How do we solve this equation? What do you think we should do first? By the way, can I just factor the left side right now? No, you gotta first check. You gotta make sure first the equation has to equals to what first? Zero in order to use zero product property. Okay, that's your first step. Okay, so Camilla, how am I going to make this equal to 0? Subtract 10 from both sides. That's easy, right? You can always make an equation equal to 0, right? Can't you? So you must make it equal to 0. Now, am I done then? No. Then you're going to try to not solve yet. You have to factor because you got to make the left side as a product. Is the left side written as a product? No. Do you see why we learn all these ways of factoring? Because if you don't know how to factor, guess what? You can't solve this kind of equation. You see what I mean? That's why we spend so much time learning how to factor, right? These polynomials. Does that make sense, guys? So first step, you must make the equation equal to 0, as it says right here. Then you're going to factor. By the way, is this going to be a difference of two squares? No. Is it going to be grouping by 2s? No, of course not. You have 3 terms. Guess what? If it factors, it's got to fit. It has to be what?
ax squared bx plus c.
Exactly. Ax squared plus bx plus c. Does that make sense, guys? So how many ways are there to multiply first 2 terms of the binomial, right? Because it has to be a binomial, isn't that right? To get 6x squared, Bella? How many ways are there? 2 ways. What's the first way? Oh, you mean 2x times 3x, right? 2x times 3x, and the other one case is? X times 6x. By the way, which one are you going to try first? Remember I told you? The ones that are closer together, so which one? 2x and 3x. So I want you to start with that one first, okay? Of course, it's not guaranteed that that's going to be the one, but many times, like I said, they like that one first. So here, you know it's going to be, let's write it vertically, 3x plus some number and 2x plus some number. And so we're trying to factor this. How many ways are there to multiply 2 numbers and get negative 10? Yeah.
2.
But this time the order matters, doesn't it? Because you got the first 2 terms of the binomials are different, right? So they're really 4, right? Well, actually they're 8 because one of them has to be negative. Anyway, so what can you have? 1, 10, or what else? 10, 1. Remember, the order matters, doesn't it? Of course, one of the number has to be negative, correct? What else could you have? 2, 5, and 5, 2. Remembering that one of them has to be negative. Go ahead, everybody figure out what goes in there and go ahead and factor and see if you could actually solve this equation. Go ahead, everybody try. I'll wait. Okay, Sammy, were you able to come up with the right ones? No? Okay, so Sammy, we could either use 10, 1 or 1, 10. Do you think 10, 1 or 1, 10 will work here? Maybe? Okay. Turns out, who could help her out here? Yes. How about Libby?
I put 5 and actually no, 2 and 5.
2 and 5? But one of them has to be negative.
Yeah, negative 2.
So negative 2 goes with 3x?
Yeah.
All right. Okay, Sammy, let's see if it works, okay? What is 3x? Well, when you do vertically, you get 6x squared, right? 3x times 2x, right? 6x squared. And then you get the last term, negative 2 times 5. Well, you get negative 10. Now, Sammy, watch this. What's 3x times 5? You get? 15x. What about negative 2 times positive 2x? Yeah, and then when you add it together, don't you get 11x? You see how that works out? All right, good. So what does this trinomial, Sammy, then becomes when you factor? So the answer is, when we factor the left side, what do we get? Here the answer, 3x plus negative 2 times? Yeah, equals to? 0, yeah, that's why we wanted to, right? So here's me checking, and the whole thing just becomes simply 2x plus 5 times 3x minus 2 equals 0. Now, are we ready to use the zero product property? Yes, we have the whole equation equal to 0, first of all. Secondly, the left side is factored, right? So this is only true if what? If? Aaron? This is only true if what? No. So this is kind of like A times B equals to 0, right? If A times B equals 0, that's true if A is equal to 0 or B equals 0. So in this case, instead of A, what do we have? Yeah, instead of B, what do we have? So what does it mean? Remember, if A times B is equal to 0, you know that A has to be 0 or B must be 0, right? So using that zero product property right here, so we're going to use the same zero product property for this one. So what must, if this is only true if what? If your A times B equals 0, right? If A times B equals 0, A has to be 0 or B has to be 0, correct? So guess what we're going to write? This is your A is now 2x plus 5. Your B is 3x minus 2 equals 0. So
2x plus 5 equals 0.
yeah, it has to be that 2x plus 5 has to be 0, right? Or what? Or this whole factor could be 0, or what? Your B, which is 3x minus 2, has to be 0. Isn't that the only way for this whole thing to be 0? Right, guys? So something like this, right? Do you see how that works? And this time you're going to get some fractions. So that's okay. So how do we solve this simple linear equation? 2x plus 5 equals 0, guys. You subtract 5 from both sides and divide by 2. How do you solve 3x plus 2 equals 0? Add 2 to both sides and divide by 3. So who has the answer for the first factor? Yes, sir. Negative? Oh, I don't like decimals. Can you I like improper fraction. Thank you. Negative 5 over 2. What about the other one? Wouldn't the next one be positive 2/3? Not negative. You're adding 2 to both sides, aren't you? Because it was 3x minus 2 equals 0. Don't you have to add 2 to both sides? Be careful. Okay. So the first, right, the one with 2x plus 5, it becomes negative 5 over 2. The one with 3x plus 2, it becomes positive 2/3. Isn't that right, guys? How many people got the answer as negative 5 over 2 or negative 2/3?
What? I did.
Good. If you didn't, go ahead and check it. Go ahead and check. Help each other out. If you messed up, ask your members. Okay. So let me ask, Jason, were you able to figure out your mistake?
Yeah.
Good. Now, guys, what does this mean? We got two solutions, right? And there's a reason why I wrote the original equation on the right side here. What does it mean? What are these numbers represent? Negative 5 over 2 and 2/3. Yes. Right, but in terms of this original equation, when you plug in x equals to negative 5 over 2, the left side would what? Equal to the right side. That's what a solution is, isn't that right? So when you plug in negative 5 over 2 on the left side, guess what? The left side would be 10, wouldn't it? What if I plug in 2/3 to this left side? When you plug it in, you should get left side would equal to what, guys?
0.
Not 0. That's when we, okay, 10. You will get 0 if you, at this point right here, when we made it into equal to 0, then yes, the whole thing will be 0, right? But if you look at the original equation, if I plug in those two, right, solutions, it will equal to 10. Does that make sense? Right? It don't equal to 0 because we subtract 10 from both sides. You see what I mean? What's an equation? I mean, what's a solution of an equation? When you plug it in, the left side would what? Equal to the right side. So if you plug into the original equation, wouldn't the left side be equal to the right side? So it will be 10 equal to 10, right? The left side would turn to 10, right? There were two ways for this to be true, right? If you plug in x equals to negative 5 over 2 or 2/3. Does that make sense? Of course, when you make it equal to 0, right? It will be 0, but right? When you look at the original equation. That's what solutions do, right? It makes the left side equals to the right side, doesn't it? Okay, let's move on to the next example. Take a look at example 5. We got 18x to the third plus 66x squared minus 24x equals to 0. This time, they're kind of nice. They made the equation equal to 0 to begin with. So, guess what? All we have to do is what, guys? Factor the left side. Do we know how to factor the left side? What is it that you're going to do first? Michael? Thank you. GCF. Always look for your GCF, okay? Go ahead, everybody try. I'll wait. See if you can factor the left side. It's already equal to 0, so. Go ahead, everybody. Yeah, don't forget GCF because that's if you forget that, then it gets really, really hard. Okay. Good. So a lot of you seem to. So Carolyn, what did you do first?
The grade I found the greatest common factor.
Yeah. What is it?
6x.
6x. How many people got 6x as the greatest common factor? Very good. So if you got that, you would have put this right. 6x times 3x squared plus 11x minus 4. But right now, we got a trinomial inside. Guess what? We have to also factor that in order for us to actually get the answer. So when you factor, well, there's only one way to get 3x squared, isn't that right? So, and negative 4 is not that bad. It turns out, right, you need 3x here, and then negative 1 with 3x, and then 4 with x. How many people got this so far? All right, how many solutions do you think you're going to get? 3. You got 6x times 3x minus 1 times x plus 4 equals 0, correct? So this is only true if what? Mimi?
6x equals 0.
Good. This is true if 6x equals 0 or?
3x minus 1 equals 0.
Good. Or?
X plus 1 equals 0.
X plus 4 you mean, right?
Yeah, x plus
Okay,
4.
x plus 4. Right, guys? Lindsay, can you tell me what we get then? For the first one, you divide both sides by? By 6. What's 0 over 6? 0, right? 0 over any number is 0, right? Except 0. Okay, what about the other one? 3x minus 1 equals 0. We add both sides by 1 divided by 3. What do we get? 1/3. The other one, x plus 4 equals 0. Claire, what do we do for the third one? We?
Subtract 4.
So what do we get?
X equals negative.
Yeah, so how many solutions are there, guys? 3. There. So here, how many people got? Negative 4, 0, and 1/3. Raise your hand. Easy enough?
Yeah.
Can you do something like this for your homework?
Yes.
Okay, all right. Let's try one more. Here we go. I put a star on this one here. X squared times x squared minus 5 equals to negative 4. This one's kind of nice. The left side is already factored. So could we use zero product property right now? No. Why not? That's yes. One person knows. 2. Brandon, why not? Yeah, on the right side it equals to negative 4. So even if the left side is factored, that doesn't really help us too much. It's only good if it equals to 0, right? So what are we going to do next? Here. Indira, what should we do?
We should add 4.
Add 4. Exactly. Allah, what do I get when I add 4?
X squared minus 5 plus 4
Yeah,
equals 0.
exactly. Equals to 0. Okay, so write that down. I'll wait. So this is what we get. So what do I do next? Look at the left side. Serena, what do I need to do here?
Well, 4 is this perfect square, so you have to like square.
Well, what about the first term? That's not perfect square. Are you talking about this being a difference of 2 squares? It's not, because it's plus 4, so it can't be difference of 2 squares. So what are you going to do here? You right? Yeah, you got to multiply it out and write into a, right? You have to simplify the left side, right? Because do you know how to factor that left side right now? As it is? No, you got to multiply this out now, right? So how do you multiply x squared times parentheses x squared minus 5? You distribute, right? Kira, tell me what to write.
X fourth minus 5x squared plus 4 equals 0.
Exactly. Now you have a trinomial. Now we have something we know how to factor, right? Right? You got to use the bow tie method. Does that make sense? Right? Go ahead, everybody try. Now this is x to the 4th power, but you know, instead of x, what are they using? They're using x to the 2nd. You can see the middle term, right? Instead of x, they're using x to the 2nd. Isn't that what they're doing? All right. Okay, go ahead, everybody factor. So it's got to be, by the way, how many ways are there to get x to the 4th? Arvin? 2 ways? How?
No.
Remember, instead of x, they're using x to the 2nd power. So how do we get x to the 4th? There's only one way.
Yeah.
What? How? X squared and x squared. That's the only way. Isn't that right, guys? Right. So you just have to look for, right? Because you know that they're using x squared as the x, right? Because the middle term has x squared. So what do you think we need here? X plus negative 4 and negative 1. Would that work? Zareth is correct. right? If you don't believe me, multiply it out, right? X squared times negative 4, isn't that negative 4x squared? What is negative 1 times x squared? Negative 1x squared. What do you get when you add them together? Don't you get negative 5x squared? All right. So do you know how to, so this becomes this, right? We're done, aren't we? No. Why not? This is.
They're both different.
Thank you. Now they're both difference of two squares, aren't they? Okay. So what does x squared minus 1 become? One person knows? Come on, everybody. 1 is, remember, 1 is 1 to the what power? A lot of you forgot this. 1 to the second, right? Okay. Somebody I haven't picked today. I haven't picked over here. What do you think, sir? X squared minus 1. James, what do I get? I mean, yeah. No, x squared minus 1. How do we factor x squared minus 1? Isn't that difference of two squares? Yeah, x minus 1 times x plus 1. Ria, what about x squared minus 4? Isn't that difference of two squares again?
Yeah.
What does that become?
So it's x squared minus 2.
Good. X squared minus 2?
Oh,
X squared minus 4 becomes? What is your a in this case? X squared minus 4. Your a is? X? No? Not x squared. It's just x.
minus 2 squared.
No. Okay, what if I wrote it this way for you? Your a is x, your b is 2. What does that become? For difference of two squares, how do we factor x squared minus 2 squared? Ria, if I have a squared minus b squared, what does it factor to?
A minus b squared.
No, becomes a minus b times a plus b. Do you remember? Okay, so your a is x here, your b is 2. It becomes
Minus 2
times.
x.
Exactly. Do you get this? Yes? How many solutions do you think you're going to get for this one, class? 4. You can already see what they are, but let's just write this down. So this is true only if, Daniel, what? Now we could use zero product property, right? Instead of a times b equals 0, we have a times b times c times d equals 0, right? So this is only true if what? Daniel? When would this whole thing be 0? But don't give me the answer yet. When would this whole thing be 0? X plus 1 equals to 0 or what? How many ways are there for this to be 0? 4? What are those 4 ways? Whether x plus 1 equals 0 or what? X minus 1 equals 0 or what? X plus 2 equals 0 or x minus 2 equals 0. You're doing that already in your head. I want you to write this step out. Then, of course, Daniel, you're right. You get x equals negative 1, right? Subtract 1. Add 1 to it, you get x equals to 1. Subtract 2. Add 2. That looks like 1, doesn't it? Okay, so somebody tell me the answer. What's the answer? How many answer solutions do you get, guys? Well, Kira, what are your solutions?
Negative 2, negative 1, 1, and
Thank you. You even wrote it in increasing order. That's good. Do you guys get this? Do you see why factoring is important? If you didn't know how to factor, would you be able to come up with the answers? No. Do you see why it's useful? Okay. One last thing, real quickly. This one's actually simple, but I just want you to be aware of it, okay? Take a look at this one. This is really nice. It's already factored, left side, and the whole thing equals 0, right? It says 5 times x plus 2 times x minus 1 equals to 0. How many solutions do you think you're going to get for this? 2? Don't we have 3 factors? Look, we got 5, x plus... Don't we get 3 solutions?
Yeah, but when you multiply 5 by the other ones.
Right, very good. You actually get 2 solutions. Let's write it out. This is true if what? 5 equals to 0. Will 5 be able to be 0? No, this is never true. Will 5 ever be 0? So what should you really do when you have something like this? Yeah. Yeah, you just divide both sides by 5 first. That's 5 is just a constant, right? Does that make sense? So you just divide, because you're asking yourself, when will 5 be 0? 5 is never 0. What is 5 equal to? 5 is always what? 5 is always 5. That's why it's 5. Constant number. So you do that, and then you get x plus 2 times x minus 2 equals 0. Yeah, some people tell me, oh, there should be 3 solutions because there are 3 product, right? 3 factors. But you just divide both sides by 5. What's 0 over 5, guys? Isn't this undefined? 0 over 5? No, that's when you divide by 0, not divided by 5, right? 0 over 5 is just 0, right? Does that make sense? So what are your solution? This is x equals 2. This is true if what? X equals 2. Oh, x plus 2 equals 2. 0 or x minus 2 equals 0. So you get two solutions. X equals 2, negative 2, or x equals 2, 2. Okay, so please be careful with that one. Okay? Easy? Do you see why we need to be able to factor? Okay, good.